What I want to talk to you about today was this technology called context and dependency injection, also known as CDI. So it's actually part of JEE. It was part of JEE 6, and it's also part of JEE 7. A lot of people may not have heard of it before, but I used it a small amount in a prior program, and it's kind of fun actually to work on this because I was able to use some of the newer technologies. So let's dive right into it. So CDI basically is a framework for building server-side Java applications. It is possible to take it out of the server side and use it in a standalone application, but I don't, based on what you'll see, I don't think you really get a lot of benefits out of that. It's designed to integrate different tiers of the application fairly easily. So you can think of something from the web tier, such as a servlet, a REST service, a WebSocket application, and maybe be able to make it communicate with other parts of your application. And then the big thing that I really like with the way some of the JEE stuff does work lately is it favors convention over configuration. So you're not going to have piles of XML. You're going to have very little XML, and in a lot of cases the configuration is optional if you accept all the defaults. All right, so I'm going to make this kind of silly app out of this called the What's Broke app. The goal with the What's Broke app is you can think about the child over you lent to your grandparents for the weekend, and they're breaking all their stuff. So what goes into the REST service is observations of what they broke and when they broke it, and you'll get a ticket number back out. The REST service is going to write to some kind of DAO. The DAO in this is not actually really writing to a database. It's really just a hash table. But for the purposes of this talk, the actual persistence part isn't that important. And then it's also going to send an event to a WebSocket, which would allow you to track what your kid broke in real time. Let's talk about some of the key components in this. So dependency injection. So I don't want to belabor this because most people are fairly familiar with dependency injection these days. But what are the main reasons we do use dependency injection is that it reduces the need to carry unneeded dependencies. Been working on some legacy code lately that doesn't use it, and it's pretty amazing seeing like all the baggage from constructors of having to pass 5, 6, 7, 8, 9, 10 arguments around, and then the caller of that has to manage those inputs. We want to be able to isolate the changes in those dependencies when we do need to change them out so that we have looser couplings. And we want to be able to reuse those dependencies. So if it worked in one place and we've got a similar operation going somewhere else, we'd like to be able to simply just inject it and not have to reconfigure it each time. And of course, my favorite part is that the code is more readable because it's not loaded with all of this configuration at each use. So how does dependency injection work in CDI? So dependency injection works in CDI by using add-inject. So that's a type-safe injection. So basically, you're going to be able to put an add-inject annotation on a field or method, and the CDI container is then going to resolve that dependency for you. A lot of people are going to be familiar with this type of injection if they have used Spring AutoWire in the past. And actually, Spring AutoWire, you can now swap out and use the JSR 330 annotations such as add-inject, because now they're a Java standard, which it's nice because also other frameworks such as Google Juice are adopting those same annotations. This is something though that I think is fairly unique to CDI, is this concept of a scope. So when you think about that application that I had up on the prior slide, it's fairly natural for different parts of an application to have different scopes for the objects that are used. So when we think about like a request, something that is so if we want to take an object and have it request scope, that means that the life of that object is going to be created and destroyed through a single HTTP request. We have some that might be session scoped if we were doing the type of application that required a server-side session, such as something that would have like a session cookie or session token. We have application scope, and that would be kind of like your classic singleton, where once the object is created, it lives the life of that particular application, and any state that's in there is shared across that particular application. fairly trivial one is at dependent, and basically that's the default that you get if you didn't configure something. So if something is dependent, so if I've got object A and it injects a type, another type, and it's not, and that other type doesn't have a scope, that object A is going to get a reference to something that's dependent. And then if object A gets destroyed for whatever reason, anything that was dependent scope just gets collected right away. Conversation scope I'm going to pretty much not cover in this because that is talking about pages in like a JSF application. And really the way we write applications today is we're not really writing the app that way. We're probably writing most of our user interface stuff in client-side JavaScript. So that's more of a server-side web app type of behavior where you're going to have a web flow. So I think maybe a analogy would be to say Spring Webflow would be another technology in that space. All right, so if we can think of this same app, we could try to break it down into different kinds of scopes. So we're going to have a REST service. The REST service is naturally fitting into something that is request scope because I'm going to have all these separate REST calls come in, and we're going to have the scope of those particular objects be on the request. Now, the DAO, like I said, I'm going to fake out the DAO in this particular application and have one that is basically just a hash table, and the data is going to be stored into that. So that one naturally fits into an application scope, but it doesn't necessarily have to, right? Depending on the type of DAO we were using, it may make more sense to have something else. The other thing is because I'm using CDI and it's part of JEE, if I was using CDI in a full JEE container, that DAO could be like an enterprise Java bean, like a stateless session bean that would have transactional behavior if it was talking to a relational database. Or if I wanted to have the application scope would be a good case for something like a MongoDB, because if you know that Mongo connector, they only want you to have one per application because it manages connections. The other thing in terms of talking or gluing different tiers together, I have that WebSocket in there. So really what we're going to have happen is that the REST service is going to be able to fire events to the WebSocket application, and then that's going to end up being distributed to all the clients that are using the WebSocket connection. All right, so let's walk through a little bit of this code. I haven't introduced all the topics yet that you'll see in this code, but I will introduce them later. So the first thing I wanted to start with in the code is really let's just start with the REST service. So the REST service is pretty simple. It's a JAX-RS REST service. So what I'm able to do here is implement that REST service, and just like we said with dependency injection, I don't really have any kind of configuration for that DAO. I don't have to worry about that at this point. So that DAO is injected into the RESTful service, and then when we either need to retrieve a record or write a record, it calls either the persist or retrieve methods on that DAO. Fairly simple. What's broke DAO is an interface, but if we wanted to use an actual concrete class, we could do that. The benefit of using the interface here is that we can swap out different implementations. So what I have here, right, is this is the DAO's interface, which is the type that I have injected here. But I have the one that's actually going to be in use is the hash map DAO. So what makes that actually work is the fact that I've got this at default on here. So I don't actually have to put any XML in place for it to pick that up. The fact that it's at default means it will just work. Now I have another one in here that you could use for testing. This is kind of a contrived example where it's a no-op one that just does nothing but just returns, constant values each time. That I have marked as an alternative. And then there is a beans XML descriptor, which then can be used to configure that. The nice thing about this is that the beans XML is optional. So as of JE 7, so the backup in JE 6, you had to have the beans XML in order for the container to know to go look for these annotations. Right now you have that by default. So this file is here just if I wanted to use these alternatives. The rest of what's in here I'll talk about in a moment. So that's pretty much just vanilla dependency injection. The way in which it's going to communicate with the WebSocket we're going to talk about in a minute. All right, so let's talk about events. Really, if you want to think about what's happening here, is when that event of that, you're having an observation that, okay, someone has broken this. So what we want to do is be able to fire that off to consumers. What I'd really like to be able to do is have that decoupled so that the producer of the events, which is the REST service in this case, doesn't really know anything about the consumers, right? And it'd be nice to be able to add consumers at any point without having to change what the producer is. So what's really neat is that CDI enables you to create an observer pattern like behavior without actually implementing the classic OO observer pattern, where you're actually able to say, you're able to inject an event handler that's tied to a type and be able to then just produce those events, and then other components will listen. The caution that I mentioned there in the third bullet is important because I've been bit by this, because it's not really, this part isn't really well documented, is that event firing, at least for me, led me to believe that I was getting asynchronous behavior. And it's actually still tied to the thread that produced the event. So that is actually a JIRA ticket against the next version of CDI. I'm sure somebody will, if it really bothered any of us, we could go in and contribute to the open source that's going to solve that. So real quick, I'm going to go back to that code and point out where I'm doing that. So if we talk about in that REST service, what we want to be able to do is say event at fire. So now all I've done is I've injected a event handler with the generic type of that the broke record, the record that represents what, like I said earlier, what that observation. So we say event that fire. Now if you notice, there's no dependencies in here on that WebSocket portion, right? This anything could be receiving it or nothing, right? If I didn't have anything set up to consume those events, nothing would happen. So let's look at the WebSocket portion. So in order to receive that in the WebSocket, I've got a method that says notify new event. And what's neat is all I have to do is put an add observes annotation on that. And now that event, well, when it's fired, that method is called passing the type in that I had parameterized in the producer class. So when I originally had to do this before in a prior version when I didn't have access to WebSockets because the environment I was working in, I did it actually with HTML5 server sent events. So that portion was actually a servlet. It's a lot more complicated to code because the servlet API doesn't give you a lot. There's an asynchronous servlet API that I used to do that, but it was great to be able to just consume that event. So the servlet just had to receive that event, and the producer didn't have to know that it was talking to a servlet.
So you said that they're not asynchronous. Does that mean that if you had a servlet that took a request and caused an event, that it basically would hold the connection open for the event to be propagated?
Well, what I was doing is on the servlet side, in servlet 3.0 and later, there is something called an asynchronous servlet. So I had a queue built into that asynchronous servlet. So the way an asynchronous servlet works is that the request comes in, there's a way to keep that HTTP connection alive, and then instead of having one thread per connection, there was a way to have one thread that would handle all the events that got put on the queue. So what would happen is the event would fire, it would put it on this queue. So now that thread was done interacting with the servlet once it was on that queue.
So it detaches the handling from
it does. If you were to, I don't know how that would have worked in the classic servlets that really were fully synchronous like that. You needed something asynchronous in there. Now there were all kinds of third-party libraries that did that, like Comet D and some of the other ones. But it was nice to be able to fire those events off like that. There is a list of workarounds for dealing with that asynchronous. So in the JEE realm, there is something called EJBs that you can put an add asynchronous on an EJB, and then that is a fire and forget method. So if I had the consumer of that being an asynchronous EJB, I would be able to get some asynchronous behavior like that. And I could also go out and add some more plumbing, use something like JMS, right? So I could have a message-driven bean consume that as well, and it would, send that to someplace via JMS. And that would give you some of the asynchronous behavior. What they want to do in the next version is have a concept of an asynchronous CDI event, so that when that's fired, the producing thread is done handling it at that point. So I think what we need to do now is we can show kind of how this works. It's a pretty simple application. So what I'm going to do is to show that I actually have the REST service. What I did is I pulled up good old Poster. I'm going to reload this, start from scratch, and say, you got Bobby and he broke some dishes. So I'm going to go and post that. So now all the REST service does is give me like a ticket number back. And all this pages, this is very simple. It's a HTML table, right, with some CSS I downloaded from one of those free CSS sites. And then there is a JavaScript, there's a simple piece of JavaScript that's calling the WebSocket endpoint. And so as soon as you load the page, it makes that WebSocket connection, and it's listening for any of the events that come in, and it's handling the messages that come back. So, I could keep, as somebody's kids, just keep breaking things, right? It'll just keep registering them.
Window.
What?
A window.
Window, breaks the window.
Yeah.
Boom, and it
Missing quote. Before window.
yeah. And nice thing there is I got that bad response error handling for free as part of the JAX-RS. So then that, pretty simple, but really nice in terms of the integration in that code. I didn't have to do anything really crazy to get those components to talk to one another.
So is this kind of like a form of long polling, or?
No, because I'm using the WebSocket, I don't have to deal with the long polling. So when I had done it before, there was something new in HTML5 called server sent events, which enables you to do a broadcast. So a WebSocket would give you full duplex communication. So what happens when you make a WebSocket connection, you call it like HTTP, the protocol has an upgrade, and then it's like, okay, now I'm going to give you a full duplex socket. And then you're able to do communication. We could actually implement a full chat system on that with low latency, because unlike HTTP, there is no header set with each request and response to go back. It goes back and forth. So basically what a WebSocket does is it gives the web browser in JavaScript the capability to do a full duplex socket, just like if you were to use a thick client. So you could implement, good old, like whether you had like a Jabber client or AOL Instant Messenger client or any of those, you could do that in something like that. What I had done before is I had used the server sent events, and that is a step above long polling, where it connects and it tricks the browser to keep that connection open. Basically what you say in the browser is, oh really, there's more data coming, there's more data coming, there's more data coming, until it's kind of ugly, until something comes and times your connection out on you, and then you got to reconnect, and then you've lost some events. But and then the APIs aren't really quite as nice. This has a much richer API. And the downside from this would be you could probably support about 65,000 connections per typical server and that's pretty. And so and each client is directly connected for the life of that session, whereas HTTP, right? Each request is separate and can be load balanced across a pool of servers. Now you could load balance it across different pool of servers, but they're going to be, during that session, they're stuck to that one server. So really, I didn't come up with this phrase magic glue, but I have read a blog post that Oracle put out, and they were saying like, well, when they were talking about how to interface with WebSockets, one of the things that was mentioned was CDI, because they had an example of how do I take JMS messages and be able to deliver them to clients via WebSocket. Well, they said, well, you use the JEE magic glue. Well, the JEE magic glue is CDI, because I'm able to take something from any part of the tier of the application. So a message-driven bean is clearly part of the business tier, and able to send that directly to the web tier, such as a WebSocket. Or in the case of that asynchronous servlet example, I could do that. I think that's pretty powerful for the way we build applications today, because we don't really have the tiering, like, you know, the textbook 3-tier architecture. We certainly have tiers in our architecture, but it's not quite as clear cut since we've gone to client-side JavaScript, making calls out to different services. So we want to be able to have that flexibility to move things around in the stack. And we want to be able to do it without having, you know, like, hey, this is Joe's secret sauce that makes it work. It'd be great if we had a standardized way to do it. And that's what this stuff provides. So to be able to do that for all the different parts, and yes, even JSF web applications, if that's the way we really want to write stuff. Wait, actually. So the next part I want to talk about, interceptors. Not really the coolest thing ever, but something that was pretty helpful. So I'm going to show you kind of, you know, the trivial interceptor, and I can talk about how I've used one before in a little bit more of an interesting way. But the classic interceptor, right, is if I want to log something, it'd be nice if I didn't have to go and like write stuff like this, logger.log all over the place. So what I can do is have an interceptor that say, hey, let's just make an interceptor that's annotation based. I want to put @log, and when I put @log on that method, we're going to go and write out the something about the method, including, say, like the parameter that got passed in that method. So we have here a logging interceptor, and what's going to happen is, on fairly aspect-oriented style, right? If I have a method decorated with @log, and I call that method, then this is going to get executed around that. And that can be, so for something like logging, that can be helpful. I've used it in another project we were doing with REST, and we wanted to keep metrics about the people that were calling us. So we had one where it's like, we would apply it to a class that was a RESTful web service. So now we were getting the, and we had a lot of information in the HTTP header about the user. So, but we could inject then who called us, you know, what their ID was, and so on and so forth. And then eventually we pushed that into a system, that Elasticsearch system, so we had nice visualizations of Elasticsearch and Kibana of what people were doing. Qualifiers. I didn't choose to implement a qualifier in this particular application, but I just wanted to make people aware of it. So one way to choose the types that are injected is by making your own custom annotations. So kind of this, I kind of contrived it to fit into this application. So I could do it on the straight up injection side, or I could actually do it on the event side. Some of the tutorials that are out there will show you, like, if you wanted to be able to say I wanted to be able to have a credit and a debit event, and be able to choose which particular, you could have a payment event and choose whether you wanted to use a credit or a debit event. In this one, we could say, well, I'm going to inject an event, you know, broken record, but in this case, I want to have one that's a severely broken, and severely broken could be some kind of, it would pick a particular subclass of broken record. You know, that's not the only way to be able to pick, like I showed you earlier. If you want to be able to pick an alternate implementation, you could use that alternatives and then configure that. All right, so I think I've hit some of the major points of CDI other than the other than the server-side web applications point. But really, if we think about this, what is really happening here, right? I mean, it kind of looks like magic voodoo. You got different pieces talking. So the first part, I think, is fairly transparent when you think about it. So a dependent scope being, it's directly injected. So if I've got a class and I want to have, I've got something that's dependent, it doesn't have a particular scope, it just gets injected in there directly. I don't have to do anything. It's really just calling the default no-R constructor on it. I don't have examples of that in this, but you can be using @postConstruct as another method that will, a class that has an @postConstruct in it as an annotation on a method will get called immediately after the default no-R constructor. That's pretty much all that's happening there. Really, where it gets interesting is in this when you're dealing with the other scopes. So, like, if you take in this application, we have the REST service, which is request scoped, and it's talking to something the DAO, which is application scoped, and it's sending events to the WebSocket part, which is application scoped. So really, how does that communication work? So what we don't have is each request directly injecting an instance of, say, the WebSocket in the DAO, because they should exist longer than those particular points do. And then the cardinality between these two components is completely different. So what's happening is at runtime, a proxy class is actually being made. It's kind of an interesting idea. So what we're taking is, we're going to take a class and we're going to subclass it automatically on demand. So basically every public method on there is subclassed. And then that proxy is responsible for mediating between the different instances that are out there. It does lead to some interesting side effects. So like if you went and put final on one of those methods, so that would mean that you couldn't subclass one of them. That's going to be an error at deployment time. You go and put that on, you go put that war out there, and it's going to fail. But I think that this is a fairly novel idea. I think that was a good way to do it. I mean, we've seen like in the past some of these types of technologies really, like some of the older JEE technologies, force you to implement interfaces, and that interface was how they were getting their shims around your objects. This way is nobody's forcing me to implement any particular interface. What they're doing is they're just subclassing that on demand. The other thing is the proxy then part is guaranteed to be thread safe. So I don't have to worry about the fact that I could get n number of those REST service calls occurring concurrently, all wanting to say send messages to the WebSocket and persist to the DAO. That proxy is mediating that for me. So that's pretty much the CDI part in a nutshell. The big thing that I want to make clear is that it allows the container to manage the lifecycle of an object, right? So I think some of the limitations of frameworks in the past is we were saying, hey, you know what, we either going to have something, it's either going to be a singleton, or it's going to be a prototype, or it's going to be a pooled object. Like I think Spring did you had the singleton and a prototype. JEE did with the stateless session beans, you had pools of objects. This basically what we're saying is, when we build applications, you can take like that diagram I had and said, what scope makes sense, particular for the application that I'm building, instead of the framework dictating the scopes effectively that are there, and then I fit myself around that. And then the other part, the reason I used this technology in the past was that glue, because how am I going to get that event that's coming in, talking to that real-time web application? And I think that it's pretty neat to be able to take any component there and be able to fire an event to a WebSocket or a server-sent event feed. So I think that this is a technology that maybe people haven't used enough of, because it's reasonably new. And the other thing that I find kind of exciting lately is, I was definitely on a project in the past where there was a lot of fighting between the Spring side and the JEE side.
It reminded me a lot of Spring.
Right. So what we're doing here, and then later on when I had to do some work with Elasticsearch, where we actually had to look into the code, and I found there was another add inject in there, and that was Google Juice. So what we're seeing here is kind of a meeting of the minds starting to occur, where we've got certain JSRs that are out here on how to do injection. Even if you don't, after this talk, go out and use CDI, one thing I would encourage you to do is maybe consider using some of those standard annotations, because if you wanted to swap from, say, Spring to Juice or to CDI, you wouldn't have to change that. And you're also going to reduce the number of vendor-specific imports in your code. So, I've got some references there if you want. One thing that I want to point out is that the reference implementation right now for CDI is Weld. And even though that I implemented this on Glassfish, believe it or not, they use JBoss as Weld, which I thought was kind of funny, because Glassfish and JBoss are competitors.
Thank you.